Have you ever taken a geometry course or calculated the area of a circle? If so, you're probably familiar with the term pi. Pi is a special type of number that cannot be expressed in algebraic terms. It's called a transcendental number. There are many special numbers in mathematics that can be expressed in unique ways and used for unique applications.
Alright, now time for some problems. In this problem, we have Jerry, and he has an apple pie. The radius of his pie is 4 inches. When he's trying to cut it, his hand slips, and he produces this weird-looking shape. What we do know is that when we take the two radii from the center of the circle and we connect it to the two endpoints of the shape, it produces a 90-degree angle. And our job is to find the area. So, for these kind of area problems, there are two main strategies. One of them would be to cut it up, and the other one would be to try to encompass it in some larger shape and subtract the leftover area. The first one doesn't seem too promising. The second one, however, does, because we can take the area of this sector and subtract the area of this triangle. So let's write that down. So we have the area of the weird shape that we're looking for, and by the way, the brackets mean area, is equal to the area of this sector minus the area of this triangle. So let's see if we can find the area of each one individually. The formula for the area of a 90-degree sector is 1/4 times the total area of this circle. And we want to subtract the area of this triangle. We know that it's a 45 90-degree triangle because the radii are both 4 inches, and these side lengths are equal. So the area of this is 4 times 4 divided by 2. Let's see if we can simplify this. This is going to be 1/4 times pi, and the radius is 4, so we're going to plug that in right there. Minus 4 times 4 over 2. Well, 4 times 4 is 16, divided by 2 is 8. Let's see if we can simplify even further. 1/4 times 4 squared is going to be 4. So we have 4 pi, then we have our minus 8 here. So 4 pi minus 8 is our answer. And we're done with problem 1. Let's head to problem 2. Jerry is back this time, and along with his old apple pie, he's got a cherry pie. What happened is that he put his apple and cherry pie right next to each other, such that they're tangent at only one point. Given this diagram, we want to find the length of CD, where A is the center of the apple pie and B is the center of the cherry pie. Let's see what we can do. We are given that the radius of the apple pie is 4 and the radius of the cherry pie is 3. So we know that AD is 4 and that BC is 3 because they're radii. And we also know that this line DC, is tangent to both A and B, meaning that these are right angles. We also need to find the length of AB. Well, if the radius of A is 4, this length is 4 until this point, and the radius of this length right here is 3. Thus, the length of AB is 7. So let's take this trapezoid and draw it right over here. Just like so. So we know 3 lengths of this trapezoid. We want to find the last one. So we know this is vertex B, vertex C, vertex D, and vertex A. We know that these two are right angles. We also know that BC is 3, AB is 7, 4 plus 3, and AD is 4. To find this, we need to prove something. We need to prove that BCDA is a trapezoid. A trapezoid means that 2 of the sides are parallel to each other. Well, let's take BC and CD first. We know that BC and CD intersect at a right angle. Okay, but we also know that CD and DA intersect at a right angle as well. Because these 2 segments are perpendicular to the same segment, they must be parallel. So now with this information, we can solve for CD. Let's bring an altitude down from vertex B to AD. This is a right angle here. Since this segment is 3 and this entire segment is 4, this segment must be length 1, because 4 minus 3 is 1. If we want to find CD, let's label it as a variable. Call it X. And since we have 2 right angles here and 2 parallel sides, this must be a rectangle. which means that CD is x, but also this length is also x. So now we have a right triangle with legs length 1 and x, and the hypotenuse is length 7. So we want to use the Pythagorean Theorem, where we know that the square of each of the legs, when added together, equal the square of the hypotenuse. So let's plug in our values. We know that this length is 1, so 1 squared plus, and we know that this length is x, so we're going to put x squared is equal to the hypotenuse, which is 7, so we're going to take 7 squared. Now we can see if we can isolate x squared, and we can. X squared equals 7 squared plus minus 1 squared. Now let's evaluate 7 squared minus 1 squared. So we know that x squared is equal to 49 minus 1. This is equal to 48. So now we know that x squared is 48. This leads us to the conclusion that x equals the square root of 48. If we want to simplify, we can take the square root of 48 as the square root of 16 times the square root of 3. The square root of 16 is 4, so finally we get our answer of 4 times the square root of 3.